Yeah, I think recording is on. Yeah, 2 to the power n, yes. Uh, okay. Knapsack problem. Oh, actually, sir, sir told me to cover this longest common subsequence problem today uh, in this class. Mm, maybe if I can complete this one, then after that I will visit this knapsack problem. And and yes, I will cover the radix sort. I think sir told me to cover the counting sort and radix sort. Uh, that I'll do the codes in today's class. Mm, okay. Oh, so about the dynamic programming problem. Okay. Okay. Uh, okay. So let me just give a rough idea about how dynamic programming works. The correct answer is 2 to the power n in this case. Correct answer is 2 to the power n. I will revisit in this part. So the dynamic programming works as follows: that you have a problem. This is your problem. So you break it into subproblems. That I think you have done the same thing in recursion, as well as like when you did perform those algorithms on like merge sort, mm, quick sort. You did this kind of recursion. So divide and conquer. Uh, you have divided your problem into smaller subproblems, same subproblems, and now what? We also divide these subproblems into further. So now it might happen that these subproblems may be overlapping with each other. Okay. So in that case, what we are doing is we are computing the same thing more than once. Okay. So this typically increases the running time because whenever recursion is going to be called, it's compute again, it will compute again, it will compute again. And that's why then it will have, generally recursions have a like higher running time. So in the dynamic programming, what we do is that once we compute a solution, we store this solution. We use some kind of table, which is called memoization or uh, actually tableization. There are two parts, and there are two ways to design the dynamic programming algorithms. So we use these, we store these solutions, and whenever we visit some subproblem, let's say we are here and we need to find the solution of this subproblem, and it's already solved, we just use this value. Okay, we don't compute again. Like it also has subproblems, right? So we store this solution. We don't compute again. In recursion, we will compute again these solutions and then we'll find the solution and then we'll use it. But in dynamic programming, we basically store these solutions. So that's why dynamic programming is is comparatively faster and produces like lower running time than recursions. Okay, so this is basically the technique of designing the dynamic programming algorithms. So the problem that I am interested today is called longest common subsequence. So let's understand like what it wants to say. Uh, for example, actually I was talking about strings. So if you have a string like A, B, C, D, uh, you can, the subsequence of A, B, C, D is basically, all the sets, like then we have this. Okay. Then you have ABC, ABCD, and then you have ABCD code. So basically, it's the number of subsets actually of like n element set, which is 2 to the power n. So if you look at this is 4. This has sorry, there will be lot more. There will be lot more three-digit numbers. I did not cover all of them. There would be like A, C, D. There would be A, B, D. And there will be A, B, C, D. Okay, so the total number of subsequences. So the problem is like what do we say about this longest common subsequence? So you have this string A, B, C, D, E, F, G, H, and you have another string B, C, D, I, K, A, B, E, let's say. Not B, let's not repeat. A, P, Q, or A, P, H, let's say. So if we have these two subsequences, now what is the like common subsequence? So what we do is that we try to match these uh, elements of the string position wise. So for example, A and B is not a match, but B and B is a match. So we can consider B. Next is BC. No, there is no other match with B. Next C, we can see that the C is coming after B. So C is common. BC is a common subsequence. Then again D is coming after C, so D is there. Then you can see that there is no other common except H. H is again common. So BCDH is the longest common subsequence in here. Uh, so you understand what is the problem? So you have to find this subsequence. There will be a lot of like BC is also a subsequence. Okay. Common subsequence. So common subsequences. Of uh, of S1 and S2 are what? BCDH is one, BC is one, CD is one, BH is one, BDH. There are a lot of subsequences. So the longest one is this one. Okay. So we are interested to find this longest common subsequences. A also in S2, but the ordering matters. A is occurring after BCD in S2, but S1 in S1 A is in the beginning of uh, A is ahead of BCD. Okay, so the position matters. A is ahead of BCD, but in here A is behind BCD. So uh, it's actually position wise. So the subsequence is positional. We are not writing that we just taking the common element and we are just shuffling. We are just checking whether the element exists or not. It's not that problem. It's about that like they consecutive or not. Okay, in order. Okay, so we maintain the order they appear in the string. Okay, fine. So this is the problem. Yes, in sequence. Yes, it should be or in order. Okay, so the next question is how to solve this problem. Okay, what is the way to solve this problem? So can you think about some way, maybe recursive way to solve this problem? Yes, yes, that's why longest common subsequence. Oh, it's longest because its length. The length of the subsequence is number of elements in here. So it has 4 elements. And you can see that there are no common elements more than 4 in here. Okay. You cannot find a subsequence which is greater than 4 among S1 and S2. Okay, that's why it's the longest. So you were interested to find this kind of subsequences, BCDH. Okay, the problem is this one, that you have to find this subsequence, which is the longest and common to all. So can you tell me like an approach, not about dynamic programming, forget about dynamic programming. What do you think that the best way to deal with this problem? By permutations. Uh, what is the, how do you deal with this by permutations? No, no, not for coding, not for coding. How to solve this problem? A, B, C, D, K, L, A, H, B, C. Yes, the output would be A, B, C because that's the longest common chain between these two. Not A. You can see that A, B, and C are appearing in the same order in A as well as in B. Okay, so he has given me an example. Uh, some I am writing in capital A, B, C, D, K, L, and B is A, H, J, B, C. So you can see that A is a matching. Position wise, B is also a matching because B is appearing after A in here also, and in here also B is appearing after A. And we can see that C is appearing after B and A both in the subsequence B as well as in subsequence A. So this is also a match. That means longest is ABC. Okay. So now, what should be the approach? Like, how can I solve this problem? Can you think of some recursive way? or some way, anyway, you feel that this problem could be solved. Selection. So how do you select? Pointer chain can be, what do you sort? There is no numbers in here. There are no numbers. Huh? How do you sort? For sorting, we need some comparison. Sorting is a comparison based algorithm, right? So you compare two elements and then you sort them. But how do you compare A and B? They're strings. Alphabetical, okay, alphabetical comparison is what? The computer does not understand, and I also doesn't understand how A is greater than B or B is greater than M. It's, you can say the position that there's some some like some letter is appearing after another. By memory address. Memory address is not a number only. It contains letters also. It's not comparable. Memory address also not comparable. It's not. These are not the way to deal with this problem. Think about the techniques that you learn. Okay, whenever you are asked to no ASCII codes, how you come? Okay, you convert the strings to ASCII, and then you look at their ASCII values. Uh, no, there are simpler ideas also. Like, you you know a lot of algorithmic techniques, right? You have done some divide and conquer algorithms and all. Try to uh, implement. No, not coding. Forget about coding. I mean, think about uh, think about the algorithmic perspective, no? First. No, not ASCII codes. Uh, you can think about this recursion. Okay, recursive method to solve this problem. Can you think of some recursive way? So, okay, let's say you want to proceed, for example, you want to proceed in this example, A, B, C, D, K, L, and B is A, H, J, B, C. How you proceed? So let's say I follow this string first. I am at this position. I compare this one with the first position of this one, and I got a match. Okay. So I know that this is the first element and it has a match. So there should be at least one value. So I add one, whatever the value that I'm computing. Then I move to the next part of this one because this one a match. So I am also, like, here I am not using the repeated uh, letters, but there could be repetitions also. And in for repetitions, you have to check every numbers in there. Okay. So then I move to the next one and I check, okay, no, it's not a match, it's not a match, it's not a match, there is no match. Then I move to the next one, I say, okay, it's a match, it's not a match, no, not a match, okay. Then I move to B and okay, A is not a match, but B is a match. So I add B and I check, it's not a match, and then I go to C and then I find a match with C, then I add one, and then I check the rest of the element, there is no match. Okay. Now, in this case, it works very fine. That we can check only the set B and we are done with. But do you think that checking only one string is sufficient? not okay. So sometimes it may happen that in this case, if you follow your A is or appearing after uh, B, C, and D. So if you check these strings, this one is common, but there could be like other subsequence after this one. Maybe there is like, and this also has some elements in here that are common to this. And BCD, mm, like it might happen that it's not BCD is not coming in here. BCD is occurring some after some other elements, and we can have a subsequence which is bigger than that. Okay, so checking only one subsequence may not be sufficient. Okay, so you have to check like all possibilities. So the better way is to think about recursively. Hmm. So how do you think about recursively? So while you're moving from one position to another, right? So let me name these positions. Since it's a string, we can think of this as an array of characters. So we can mark this position some AI. So I position. Okay. So the strings, the value of the entries of the string, we can think of this, for example, here A, B, C, D, K, L. We can think of this as 0, 1, 2, 3, 4, 5 position. So by A0, I mean A, mm, A1, I mean B, and so on and so forth. Okay. So we can think of these elements as a array, as an element of an array. And as you know that I think in the last class I have covered some basics about strings, that it always ends with a null character. So there should be a null character also for in this array. Uh, and same goes with B. We can have uh, representations of B0, B1, and so forth. So for recursive calls, we are looking at some ith entry of A as well as some jth entry of B, and we are checking whether they are matching or not. Okay. So what we do is that we create a function. This LCS stands for least common subsequence. Uh, so if our AI is null character, that means we reached at the end of the sequence. So there is no point of going further. So same goes with the J. So we stop. We just return 0 and we stop computing. Otherwise, if there is a match, what were we doing when we find a match? We are counting +1. The same thing we will do. So we return LCS I +1, J +1. Okay. So what does it mean? That we have a match. We forget those numbers. What we are doing in here, we found a match. Just keep it. We now come to these two positions and checking whether they are matching or not. Now, if there is no match, we compute this one, maximum of incrementing one, and Once we increment j, once we increment I. That is one time at a time. I am just checking whether if we increase the value of if we take the next element in B, then what happens? And if we take the next element of A, then what happens? We are checking these two scenarios here every time. LCS is just the function name. It's for least common subsequence. It has nothing to do with this. This is the function. Okay, this may be. It's confusing. Okay. So this is the recurrence relation. So how this recurrence relation and how this algorithm works. So let's just take an example and see. That could be a bad example. There is no. Sorry, the examples are. Yeah. Okay. So we start with, let's say, VCD and B some BD. Then if we follow the algorithm, let's follow the algorithm. What do? We start with A0, B0, right? We start with this A0, B0. So what do we have at A0, B0? Is it common? This is 0, 1, this is 0, 1, 2, 3, and there is also 0 character, so 4, 3, sorry, 2. Null character, this is the null character. Okay. So A0, B0, the 0th position, there is no match, right? So what do we do when we have no match? We increment at least one, increment one of them and look for the maximum one. Okay, so what do? We go for the next one, which is A1. We check for two problems, A1, B0 and A0, B1. Right? We check these two problems. Now, what is A1, B0? A1, B0 is A1, B0. See, this is a match. This is B, this is B. So this is a match. Okay. So when there is a match, our algorithm says that, okay, we increment one and then we go for the next round. So we directly go to this one, A2, E1 with 1 plus. Okay. And next in this part, A0, B1, A0, B1 is not a match. So we further expand it into two parts. That's A0, B2, and A1. So B1. Okay. So A0, B2, B2 is a null character. So this will return 0. Okay. There is no computation after that, and this is completely n. So we have hit 0. A1, B1. A1, B1 is not a match again. So we again hit 0. No, sorry. We call it, so if it is not a match, we call again the sub-problems. We check the maximum of it. So we call this A1, B2 and A2, B1. So A1, B2 is, see, B2 is 5. B2 is null character, so it's 0. And A2, B1, A2 is C and B1 is D, so this is not a match again. So you have to further break it, which is A2, B2, A3, B1. Okay, so A2, B2, B2 is again 0. So A3, B1, this is a match, I guess. Yeah, see, A3 is D, B1 is T. So this will give you 1 plus B2, A2. Now B2 is 0. B2, A2 is 0. So basically, I'll get 1 from here. And if you expand this part, A2, B1, A2, B1, that's not a match. So you break again, A3, B1, A2, B2. You know, A3, B1 is A3, B1. This is a match. So I get 1. Plus, which is 2. 1 plus 1, so this is 2. And from here, I'll get actually, let me write 1 plus, this is a match, so okay, 1 plus 1 plus A, A4, B2. And if we expand A2, B2, A2, B2 is C2 and B2 is empty. So this is 0 because B2 is pi, B2 is null character. So A4, B2, now B2 is again null character. So I'll get 2 from here. Now you can see that at each step we are computing the maximum, right? Computing here, at each step we are computing the maximum of these 2. Maximum of the children. So maximum of these 2 are computed. Okay, in this note. So the maximum in here is 2. So 2 will come up to this, and the maximum of this here is 1. This will come up to this, so the answer is 2. Okay, and you can get back to you can follow the tree to find which are the common elements. Okay, so what is the step, and how does it execute it? If you closely look at, we actually expanded at least one of the subsequence, one of the, like, we have used at least like all the subsequences of at least one of them. Okay, so that means that we checked every possible subsequences of one sequence and we tried to match it with other one. So this is basically that algorithm. Okay, so this algorithm takes order 2 to the power minimum of mn time where m and n are the lengths of the subsequences. Okay. So now the running time is quite high. So the better approach is the dynamic programming algorithm. Now, while designing dynamic programming algorithm, there are 2 ways to design. One is bottom up, another one is top down. So in both ways, you can design this LCS problem. So the bottom-up technique is quite useful than the top-down. The top-down uses memoization. Uh, so let me discuss the bottom-up approach. I think because the top-down is already like top-down is mostly this one. It's just using a table to store the solutions that I have said. Or you can view it from here that whenever hmm, we are calling this function, it goes to these two functions, okay, and then it goes to here, it goes here, and it computes. And you can see that we are using A2, B2 in here, okay. So it always computes this one. When you are using recursively, there are like these are problems that are occurring. But if you store them, okay, if you stored them on beforehand, then you don't need to compute at this end. You know that this value is 0. So you will not compute. Okay. So that's how you can save your running time. Similarly, like B3, B1, you know the value in here and you can solve it. So what the bottom up, the top down, sorry, the top down approach uses memoization. So basically, this memoization is a table. You can see that if you have a table of this A, B, C, D, and these numbers, so how do we fill the tables? We know that when it's 0, we'll get 0. So when it's null character, we'll always get 0. So at the end, it will always be 0, right? Now, in this position, when there is a match D and D, we get 1. Okay, right? We get 1. And this one that we get in here is basically this one that we get, A3 beyond. And we carry this solution. You can see that this one will be carried in here. This one will be carried in here. Okay, so this one will be carried throughout till the root. Okay, so if you look at the, like, what would be the next problem? If you look at this A, A2, A2 B1 problem, for example, here, it's basically calling this A3B1, which we have computed as 1. So we can store this A2B1 also as 1. And then we can also store this DB, which is basically DB is what? DB is nothing but D is A3B0. No, wait. Not DB. Oh, it would be AB. So A1, B2, A1, B2 that we have in here. Sorry, A1, B1, A1, B1 that also stores uh, this. This is A1, B1. This is also store 1. And the next solution is A0, B1, which is this one. This also stores this one value. So this is how we compute it. And then we move to the next table, C. We don't compute this A, A3, sorry, A3, yes, A3 and A3B1 A3B0 and A3B0. We need to compute A3B0. Okay, so that doesn't occur in the whole scenario, so we skip it. There is no entry in there, and also there is no entry in I think BC also. That is A2B1, A2B0, A2B0. Yes, we also don't visit this one. Now we visit this A2B1. A2B1 is this one, and we have already computed this A22 as 0. From here, A2 and B2, A22 is 0. So we computed this one, and we have the value of A3B1 that we have stored in here. A3B1, yes, A3B1 we have stored. So the sum of these two would be 2. So this value is 2. And obviously here the maximum will be among these two values. So this is how we get the maximum, and this is the length of the longest common subsequence. Okay, so this table, to fill up this table, the time complexity is same, order mn. Why? Because there will be like length of the one subsequence is n, another subsequence is n. So to fill the table, so the table size is order mn. So the time to check all the entries and fill up, that will take order mn time. So it's an improvement over the 2 to the power mn running time. But still you have to do like a, so this is, I mean, still it's not a best approach. Uh, the bottom up, so this is a top down approach. The bottom up dynamic programming is basically the best one that we can apply in this problem. Okay, so let me write the bottom up dynamic programming problem. Table is filled according to according to this division. So I would suggest that you break it using the same algorithm that we have discussed in here. Okay, I also break it. You can check the values, and from there we can fill this table, because you know that the last entries will be 0. Now when we are at this situation, what we are doing, we are calling one of these problems. Okay, it's a bottom up, it's a top down technique. So at certain position, for example, on this node, on this part, we are calling these problems, and we also check whether this is a match or not. Okay, so based on that, we are adding one, or and looking at the next sub problem. So we add one and we look at the next sub problem. This is 0, so this would be 1. Now when we are at this node, we check the previous nodes, which are this one, previous positions, which are this one, and then we take the maximum one. So this one got carried till the up, till the top of the tree. So for example, you can see that one occurs here, and this one is got carried in here, this one got carried in this node, up to this node. So the same thing is happening in here. If you follow that path is nothing but this one, that path is nothing but this one. Okay, and once we reach here at certain node, uh, now when we go to the next part of the computation, it actually, you can see that it starts with this 2 value. And how does this 2 comes from? This comes from this A3B1 that we have already computed in this part. See, A3B1 is already computed. We know the value 1. We can directly use it. We don't compute further for A2B1. we know that this value is 0, we know that this value is 1, we can directly compute this as 1 and we can use it. So for example, you can see the table in here, A2, B2 is what? A2, this is A2, this is B2. So A2, B2 is 0, we see this is 0. And then we see that there is, this one is, and the other one is A3B1. A3B1 is, A3 is 0, 1, 2, 3. A3 is this one, B1 is this one. We know that this is 1, and the value already in my hand in this position is 1. So I stored 1 plus 1 in here, which is 2. And next part is A2B1. So A2B1 is not computed, I think. Oh, A2B1 is already, so already computed A2B1. So you can directly use the value 2. You use this value 2 in here, which is A1, B0. So A1 is this one, B0 is this one. So I get this value 2, and I can directly get this value 2. Okay. Okay, so let me just do that once more. I think the last part is confusing a little bit. First one is, I mean, the lower part is easy. This one is always 0. The ones are coming from this side. If you follow this subtree, you will get the ones. You may be confused with this 2 part, that how come 2 occurs when we have to look at this subproblem, but we don't have to look at this subproblem because we have already computed A3B1 in this node, and we have computed A2B2 in this node. We know that it's 0, and more than that, we already have the value of A2B1. A2B1 is stored already. So we can directly, when we are at this node A1, B0, if you look at this one, this is A1, this is A1, and this is B0. So we at this node, we already computed, so this is a match. So there should be 1 plus the next value. And the next value is A2, B1, which is already computed, and the value is 1. So we can directly use this value, plus 1, to get this value. And since this is a common one, at this node A0, B0, the maximum out of this 2 will be carried, which is 2. Okay. So the other way you can check is that think of these as 0, zeros. Okay. So the other way to think about, okay, let me just explain also. So the other way to think about this one, A, C, D, now character, T and B. Okay, so these ones are 0, there is no doubt in it. Now this is a match, right? So there should be 1 plus. So 1 plus the previous solution, and the previous solutions are one of these solutions, so which is 1. Okay. Now this 1 got carried through this table. If you follow the tree, you will see. Okay. Now the next part that occurs is this one, where we have 2 common values, A and B. So B are common, and the next solution should be this. So we get 2, and the maximum of out of this 2 will be carried, so that would be 2. Okay, so this is how the table was constructed. It's just you follow the tree, it will be there. So next technique that I wanted to discuss is the bottom-up dynamic programming, not this one. This one has a little bit drawback about implementation. So this bottom-up dynamic programming. So the algorithm is, so if this is equal, then I call the next part. So we move one further. Okay. And otherwise, consider the maximum of okay. So now how this is different from the original table is that is the above code is that how you fill the tables actually. For here we use the what is called tabulization. So table is a bit different. Now we consider only this part. We don't need to consider the null character. We consider P and D. Okay. So what we do is that in the beginning we assume that everything uh, that we start with that have 0 in it. Okay. Now we try to fill the table from here. So this is your 0, 0 location. Okay. So the table actually fill from top to bottom. See, in bottom up technique, in top down technique, your table was filled from bottom to up. Now in this bottom up technique, your table will be filled from top to bottom. Okay. So first we consider that all these initial values, they are 0. Okay. So so now what we do is that we also left, okay, sorry. We should also left one character for this one. We assign 0 in everywhere. Now, let's say we move to the next position. So if you see that the minimum of these two, since we are moving from one character to other, and it's not same. So that means we will check to the next solution, and this one should be 0. Similarly, this one should be 0. Now, B and B, this is a match. So we have to add 1. So we add 1 and we go to the next solution. And since this is 1, so from this 2, we get 1. Now, from this 2, we take the maximum, which is 1 in here. And from this 2, we again get the maximum, which is this one. And then to fill this one, we take the maximum of this one, which is 1. Now, D and D is a match, so there would be 1 increment. And in the previous, it's always 1, so it's 2. Now, to find the solution, we just need to move the diagonal and follow the path. till there is an update. Okay, so this will give you the dynamic programming corresponding to this problem. And this is a corresponding algorithm. I think it's better if you try to take an example. For example, here I have executed this one in here. You can take an example and you execute the code in there, execute this algorithm in there on your own hand, and then you will know that how this algorithm works. Okay, fine. Or any questions? So this both have the same running time, but this tabulation has a better space complexity than the memoization one. Actually, it's the same, almost same. So it's not improvement over the running time, but this approach is easier to follow. Okay. So if there is no question, then I'll shift to the coding. Okay, so oh, okay. So it's about how you are solving the problem. See, uh, in the bottom-up technique that we use in here. So how does it operates? You have to understand first. Okay, so mm so at certain position, what we are doing, we are checking whether it's a match or not, and if it is a match, then we check the previous solutions, right? That's already been covered. So now, see, we have to make the initials 0. That's why we assign these zeros to the initial problems. And then we move to A1, which is basically we go to this. So if you call, let's say, okay, let me execute it on this array, then I think it will be better for you to understand. So if you think about this A0, B0, okay. So A0, B0 will look at somewhere, but there is nothing in there, right? We have assigned 0 for those places. 0 for those places. So A0, B0, in this case, your LCS, which is LCS basically what do you say? LCS 00. This will look at some part where there is nothing actually. So corresponding value will be 0. Okay, so that's why you have this 0. Next, you have LCS, let's say 01. If you have 01, then you look at which problem? This problem. They are not matched, right? They are not equal. A and B are not equal. So you look at this problem that 1 0 1 0 0 and 0 1. Now 0 0 is 0. So the maximum out of it is 0. And j minus 1 is I minus 1 is also 0. So that's how you get L010. Now, if you look at this next problem that you look at will be L1. If you look at L10, L1, B1, 0, yes. L10, then it's a match. So it should be L1, 0. Now 0 minus 1, which is basically this position that they're talking about. And this is 0. Basically, this part is 0. So you get only 1 in this case. Okay. So that's how you get this one. So what you're computing, if you look at the table wise, basically for certain location here, I'm looking at this location, which is I minus 1, j, same j, I minus 1, and here it's same I, j minus 1, or rather it's the opposite one actually. It's I minus 1 j, and it is I j minus 1. What is this I j minus 1 and I minus 1 j? If this is your ijth coordinate, this should be your I minus 1 j, I minus 1th row and jth column, and this should be your I j minus 1, right? I throw j minus 1th column. Okay, so you check only these two, and that's how we are filling this table. Okay, let's check these corners and we find the value. We check these corners and we find the value. That's how this table goes. You just compute manually, you'll see that how the table goes. And the table size is order mn, so again its complexity is order mn. Okay, so there is no improvement, but it's like mostly implementational improvement. Okay, so any other question? Those zeros that I set in the first row of this one and first column of this one is to initialize our dynamic programming. Okay, so that whenever I'm looking at some solution which is not covered, which is not in which is the initial stage, then there should be a value giving it, like when I'm checking the sub problem, there should be a value. So that value is ensured by this 0. Okay, so is it fine? Or I think you'll better understand if you take an example and you execute it. It's easy. It's not that difficult. Okay. Okay, so I'll move to the coding part now. So what I'll do is I will solve the counting sort problem. Okay. So let me shift to the computer. Okay. Mm. Yeah, I cannot log in. Okay, let me that will take a little time. Just wait, okay. There is a problem. My computer. So is my screen visible, right? Screen is visible, I think. Yeah, it's actually the login issue. Uh, it was saying my laptop as a external device. It was not allowing to enter. Okay, fine. So let's start. Uh, so since you guys asked for the codes of counting sort and radix sort, so what is a counting sort algorithm? If you remember, any one of you. Okay. In the counting sort algorithm, we actually it's a linear time sorting. So it works on a specific set of input. It doesn't work on every input. It has to be, the input has to be within a range. For more, like, you can check the algorithm. Anyway, so let's start. So actually we need pointers for this. So integer should be between some range, and we will run that. We'll run this counting sort algorithm through a function where the input of the function would be the array, and the integer n by which it's bounded. Okay, so okay, okay, hold 1 second, I'm coming, just 2 minutes. Okay. Find the function. So the input to the function would be an array that we need to sort and an integer n. So okay, how does, like, do you guys like remember how this uh counting sort works? I mean, what is the algorithm? Hmm, anyone, like how this counting sort works? Inserting number in array of queues. Yes, array of queues. In array of queues, what is the array of queues? Mhm. Okay, so yes, by counting all numbers for all one, we have a queue, and for all two like this. Yes, so you count the number of elements, right? Count all numbers, that how many times that numbers occur for each number. Yes. And then what do you do after counting the numbers? That how many times? How do you sort these numbers? So find a range. Range of what? Yes, I mean that's how the counting sort works. That your element should be from a certain range. That it should be bounded by, like not bounded by. I mean there is an integer up to which you can take. Uh, yes, you can consider the ranges. Then how is the sorting? How do you do the sorting? Okay, so basically we have to take an array which will keep count of the number of elements, like how many times they're repeating or and all. And from using that, we will actually sort these elements and put it back again inside the array. Okay. Okay. So let's start. Hmm. Okay. So so we need to find the range, right? So how do you find the range? By finding the maximum element of the array. So that's the first thing we'll do. So find the maximum element. Let's say we initialize it at 0 and then we repeatedly find it. So finding maximal is order n time process. Uh, just run a loop. Mm, yeah, it's not initialized. Like 0 and plus plus. If if our array equal to pi. Okay, so this is how we can find the maximum element. The range of it. And now we will initialize what is called that someone is saying that queue, uh, which is actually can be done with an array that we define right now. Mhm. So it's using pointers. And so define it as count. So it's for that actually I'm using this dynamic memory allocation, uh, which is denoted by this malloc and calloc. Here I'm using calloc. I think you are not familiar with these calloc settings, are you? Do you know calloc? Let me write, then you might. Okay, so I think you are not familiar with this calloc. So there are like, it's just a function uh, that actually used for this dynamic memory allocation. Mm, So dynamic memory allocation is that uh, like suppose when you declare an array, you declare size of the array, right? You declare that what is the length of the array, 4, 5 or something, or 100, 200, whatever you mention the size. So after you declare that, the memory will declare that many blocks for uh, array for that array corresponding to the variable that you have named array AI or whatever. Okay, so this allocation, this is like specific you have mentioned, and it will allocate that new space. But in terms of dynamic memory, what happens is that this is not fixed. Okay, it's depending on how you want to manipulate your entries. It's totally depending on that one. So there is like no specific places where the values are stored. Okay, so that's what the dynamic memory allocation is, and this function calloc is corresponding to that dynamic memory allocation. Okay. So now okay, so now we define that array that corresponding to this count, that where the where we can store the number of times the one number is occurring. Okay. So that is done by this function, by this part. So array. Oh, we store the elements of array at the index of this array, and we keep on increasing that. Okay. So now we have that array. Now we have to they compute how many times values are occurring. So that is done in this step. Okay. Now we have those numbers. Now we convert this back to what we wanted to compute. The third array is which would be the shortest array, sorted array. So here, again, I'm using the dynamic location. You can see okay. Now hit this array. Now we just copy these elements back to the array. Whenever we use this dynamic memory allocation, we see that.
is yes. P actually, when we use dynamic memory allocation, there is no specific bound on the space on the memory space that you have located. So after free, you release all those memories. Okay, so free is important for that command. Whenever you are using malloc and calloc, that is this type allocations you have. Yeah. So uh, yeah, is it clear now? So, is it clear now? Yeah, yeah, yeah. I think there is a problem. The code 234. Uh, check. This problem. N after malloc. Are you talking about malloc? Yes. What is the question? So what is your question? Oh, okay. So your question is argument of malloc. Actually, it's not like that. For that was for calloc. For malloc, it's actually same thing. Like it allocates memory for n integers for some integers. So this n star means that you have allocated memory for those spaces uh, for those n number of integers, capital N number of integers. So it's not like that. So you want to use calloc instead of malloc. So it's actually both are different functions, are not same. What about using calloc? There is an extra computation for about size. About size. Correct, 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 correct. Four, it's not taking. Is it out of size? It's not in the last element. properly again. Mm, okay. Copying back. Is it working properly, the code that you have shared? Okay. The same code actually. It's always same. Just difference in the input size. I think that there may be an error happening when I'm copying back this elements into the array again. There is an issue. So if this code is working here, then fine. You can follow that one. Okay. I think that there is an error. Maybe it's this is a problem with this kind of allocations. Okay. Okay, so you can follow that code. Uh, hello, hello, hello. Is it clear? I don't know why. I think there is some issue with the mics. It's not coming loudly. Uh, so if this code is working fine, actually this code is like similar code that I have written. So I think the issue is while we are copying back, when I'm copying back those items, then so when I'm copying back those items in the array, there may be an issue regarding that. So uh, all the elements are sorted except the maximum one, I guess. It's because of that this copying process. So, because of this copying process, I guess. So I'll look into it and I'll check whether what is wrong with this code, and maybe I'll share it in the next class. Uh, so in today's class, so you guys also wanted to do the coding for the radix sort, right? Counting and radix sort, I think. Is the radix sort algorithm? We sort this element. We first according to their digits, right? We process each digit. We process the elements digit by digit, and then we uh, solve this. So uh, yeah, no, it's C plus code. It's a C plus plus code. So no, it's fine. It is working in C plus plus. It's just C plus plus code and C code, so there is a difference. Uh, but okay, if it is working fine, then it's okay. Is this code is working fine, or is there any issue with the code that you wanted to check? Okay, but the two platforms are different. So that's why I don't want to run this C++ codes. So if you have done this C++ code, it's fine. It's okay. It's good. Let me just go through it for once. Uh, yes, same algorithm. It's just yeah. Okay, that's a good one. Yeah. Okay. 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 Yeah, maybe. I mean, I don't know why this is creating problem. Uh, I have to check it. And is some issue. I think there is an issue with the maximum element. I guess it's not properly copying back to its position. Instead of finding the maximum, it is taking. There is some issue. Uh, I have to. I'll look it. Okay. Yeah. Okay. Then if it is working fine, then it's fine. You guys can go through that code also. That is that Roshan shared. Can go through that code. It's if it is working, it's a C code. So if it is working, it's fine. And there is a C++ code also. So if you are comfortable with C++, you can go through that one. Uh, shall I go for Reddick sort or uh, let's end the class today? Okay, fine. So what is the Reddick sort algorithm? How do we proceed? This Reddick sort code we can implement it in our sort. So you come up with a if 54 125 so uh, the static sort work, right? Uh, you process digit by digit, find a maximum number, then you uh, it has maximum number of, and then you uh, digit by. So question is that can you cut the code where you can implement this direct using the counting uh, just that just is it really that much? I don't know. I think there is something wrong with my headphone, I guess. I have to. Okay. What I want is that you can implement this radix sort using the counting sort. Okay. So if you recall that in radix sort we have these numbers and we process them digit by digit, and how do we sort them on the unit place? It's using the counting sort. Okay. So basically you have to use just one or two extra loops for this radix sort problem, and then you can use this counting sort to sort those elements. Okay, and then you uh, write a function which uses this counting sort to sort the single digit to sort the digits at the unit place, and then find the sorted array. I think you can try it. Oh, network, actually there is a very unstable network in our IIT right now. Uh, I am using actually mobile internet, so maybe that's an issue because there are the connection is not actually stable. That I also find this true. Okay, so what I wanted to convey is that for the radix sort, you just need to use the counting sort uh, to sort the unit 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 place. So for the digits and the unit place, and uh, repeatedly use this algorithm to sort all the values. So you can try to write the code on its own on your own, since counting sort is already there. If not, then I will discuss it in the next class. It will be the first priority for me, and I will also. Okay, tough. Okay, okay. Okay, but I think that it will be better if I start because there is not much time left today. I will, and since I am having this difficulty with this counting sort, I will check this counting sort code. So what I am suggesting is that you guys can uh, try one more time, and if uh, you are not able to do it, I will definitely do it in the next class. I will I will check this counting sort code also, and I will find the error. I'll point it out next class, as well as I will cover the Redis sort, and that will be the priority for me in the next class, definitely, for sure. Since there is no much time left and the network issue, I think it will be better that we will try it in the next class. Okay, okay. Uh, Thank you, everyone. That's it for today. So, when is your mid-sem examination, or is there any mid-sem examination in your courses? Oh, 22. Ah, yes, sure. Yes, what's your question? Oh, uh, that also I don't know. But I think the questions are mostly MCQ and true false based. Uh, and it's easy. Like if you follow the class, it's not that much difficult. So, do you have any like assignments? I think you have done one assignments or something. Have you guys quiz or assignments? Okay. So the questions are not okay. Very easy. Yeah, the questions are not that much difficult. No, don't worry about the questions. I think, I mean, rather than worrying about the questions, you guys should like focus more on what you are learning in this class, the techniques that you are learning in this class, and try to do like solve much like more examples or more exercises based on these techniques. For example, like you are learning very important techniques, this recursion, this uh, sorting algorithms, this uh, dynamic programming, all these strategies. These are very important in designing algorithms. So if you do solve problems from different websites, different books, your ability to solve problems will grow. So it will be better if you focus on solving problems more. Then exam is the, don't worry about exams. It's that much. Okay, so um, I will cover this is basically a design analysis of algorithm course. Uh, yes, basically it should be C at first, then you should be introduced with Python. Yes, actually that's true. In BTech course also there is a C program. Not C programming. It's C plus plus. Uh, in BTech it's C plus plus. There is a C plus plus course in second year. Uh, that also in design and analysis of algorithm. So yes, C should be the first one. Yeah, I mean it's kind of opposite, but yes, C should be the first one. Then you should be introduced to the Python. You should focus on solving algorithms. Coding is the secondary part. The first part is how to solve the problem. If you are expert in solving problem, then coding will DSA Python and DSA. This is not a good question actually. Python is a code, okay, and DSA is the basic code of computer science. It's uh, it's the basic of designing algorithm. So whenever you are designing any algorithm, you are applying one of the techniques that are taught in this class. So DSA is a topic that you should know because it will help you whenever you are trying to design any kind of algorithm. Whenever, be it in your exams, be it in your job interviews or wherever you will go, you will need that knowledge. Solve the to solve the problem, you need this algorithmic knowledge, and you need this algorithmic knowledge. And this Python is a coding language, so coding is a different thing. Solving problem is more important than uh, it's coding. If you can solve, uh, actually, solve means not only solving efficiently, and how efficient you are is based on how good you are with your data structure and algorithms. So that's why DSA is a very important topic for basically CS students. Not only CS, nowadays it's important for everyone actually. So you should focus on DSA, and Python is coding. So if you are not good at coding, then you can focus on that. C++, C++, not a- Basically, it should be that you learn C programming with DSA, and then you go for C++. See, DSA is not about language. You guys, I don't know why you are asking about questions about the coding language. The coding language is just a platform to represent the algorithm. Now, some platform is easy to implement, some are difficult because it's more primitive structure. The C language is very old language. C++ is comparatively modern, and Python is very modern, so it's easy to implement. But the thing is that uh, the main important thing is to know the like, techniques how to design algorithm, techniques of designing algorithm, as well as the knowledge about these data structures. These things are very important. It's not about any particular language. You guys are mistaken DSA with language. DSA is not about language. DSA is common to everyone, and don't mix up it with language. Language is secondary.
Yes. So algorithm is the main important thing. Okay. So that's why I'm saying that the solving problem, like how you are approaching a problem, it's very important. For example, like you can see that whenever like since the last 2 3 classes in the tutorial class, I am starting with a solution which is not good, having running time higher, and then we come up to a solution which is like a very efficient solution. So this is what is expected from a good uh, like problem solver or coder or whatever, that he can solve this problem in the most efficient way. And your efficiency will be depending on well you are how well you are dealing your data structures, as well as how good you are with designing techniques. Okay, so it should be, the focus should be on solving problems, not on like writing the codes. Writing the codes is basically the practice of the language. If you practice a language, you can learn like how to write that code. Okay, practice for like 2 3 months, you know everything about that code. But the, the main thing is that if you cannot solve any problem, it's I don't know, it's a problem. So if you try to solve these things and try to solve a problem, you cannot solve a problem, but you are good at coding, then it's not valuable to you. So you have to be a good solver.
Not coming at all, no? Roadmap. Is it okay? Is it okay? The voice is coming now.
roadmap is that you start with like basic problems, and you slowly go for like, for example, you start with the basics, like what do you have covered in the like simple problems. Like a simple problems of let's say, is it okay? The voice is okay? Yes, yes. Start with those problems. Some basic problems, and then you solve them, and you can solve these problems. You can find these problems in many websites. For example, like Gigs for Geeks, GitHub, LeetCode. All of them, they have these problems that you have to code these problems. But before going to write the code, it's important that how efficiently you are solving that problem. So focus on solving that problem, and after that you go for the code. Okay, so uh, that's the main thing. I think that's the way you should approach. Okay, so thank you everyone. I will check this in the next class, and I will let you know. Yeah, so I'll check these two problems in the next class, and I will definitely cover the reading sort in the next class. Okay, so I'm closing the meeting. Thank you. Thank you everyone. Yes, is there any questions? Okay, fine. Yes, yes. Tell me. What is the question? Oh, mic. I'm not sure whether I can. Okay, I think I have allowed you.
हेलो
Yes, yes.
गुड इवनिंग सर।
Good evening.
सर हम लोग का जो हम लोग जो टॉपिक पढ़ रहे हैं सर हमें कुछ समझ में नहीं आ रहा है तो कोई सोर्स बताते हैं जिससे हम
Which topic? I mean, this design and analysis of algorithm?
यस सर।
Okay.
आज
मतलब
तक मैंने कभी सी प्लस प्लस पढ़ा नहीं, मैंने सिर्फ पाइथन पढ़ा था तो
नहीं, ये पाइथन से इस टॉपिक का कोई रिलेशन है नहीं। मैं बार बार बता रहा हूँ कि ये जो जो क्लास में हो रहा है, जो ट्यूटोरियल में हो रहा है, ट्यूटोरियल में जो हो रहा है, जो क्लास में हो रहा है, वो सी का क्लास नहीं है। वो है डिजाइन एंड एनालिसिस ऑफ एल्गोरिथम का क्लास।
यस सर।
हाँ हाँ, तो उसमें कोई कोडिंग नहीं होता है कि ये कोडिंग तुमको आना चाहिए। वो एक प्रॉब्लम सॉल्व का टेक्निक है कि एक जो प्रॉब्लम है तुम्हारा, वो कैसे तुम सॉल्व कर सकते हो। इसका डिफाइंड डिफाइंड टेक्निक्स जो डेवलप हुआ है, उन सब
यस
का
सर।
स्टडी है ये डेटा स्ट्रक्चर एंड एल्गोरिथम्स। और इसमें
सर
उसको सॉल्व करने के लिए हम लोग डिफरेंट डिफरेंट डेटा स्ट्रक्चर्स का यूज करते हैं, जो कि ये एरे स्टैक्स क्यूज है वगैरह, ये सब। तो ये चीज है, इसको तुम मतलब लैंग्वेज के बेसिस पे मत समझो कि ये लैंग्वेज नहीं है।
हाँ बताओ
सर
क्या है?
डीएसए के लिए कोई बुक आप प्रेफर करें जैसे
हाँ
मतलब
हाँ हाँ,
बेसिक्स
एक्चुअली
आए हो?
बुक से अच्छा है कि तुम वीडियो लेक्चर्स देखो। डीएसए में तुमको डीएसए में तुमको बहुत सारे लेक्चर्स मिलेंगे, मतलब
यस
कुछ
सर।
कुछ यूट्यूब में तुमको मिलेंगे, गेट के लेक्चर्स मिलेंगे, ठीक है।
गेट। यस
तो
सर।
हाँ, गेट मतलब वो गेट एग्जाम के लिए वो लेक्चर्स होता है डीएसए का। अ, वो तुम फॉलो कर सकते हो। डीएसए का बहुत अच्छा एक कोर्स एमआईटी ओपन कोर्स में है, एमआईटी ओपन कोर्स करके तुम अगर सर्च करोगे यूट्यूब में तुमको मिलेगा। तो वहाँ पे भी ये डीएसए का पूरा कोर्सेस है। कुछ शायद दो दो मतलब उसका यूनिट है, तो करीब शायद 50-60 वीडियो होगा दोनों यूनिट में टोटल। तो उसमें सारे कवर्ड होंगे,
सर
जितने
एक और
भी
हमको
यहाँ पे
डाउट
करवाया
क्लियर।
जाएगा। हाँ
सर
बोलो।
मैं लिंक स्टैक क्यू में पढ़ ले रहा हूँ सर, ठीक है, बट उसको सर
क्या
मैं कोड सर पाइथन में कर रहा हूँ। हेलो।
क्या क्या क्या? हाँ
आप, आपने जो जो अभी टॉपिक बोला लिंक स्टैक, ये सब,
हाँ
हेलो, ये सब मैं पढ़ ले रहा हूँ, ठीक है
हाँ
सर,
हाँ हाँ
लेकिन सर
बोल।
कंपलसरी है कि कोड सी में होना चाहिए? पाइथन में भी हम कर सकते हैं?
नहीं 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 नहीं, कोड तुम किसी में भी करो ना अपने पसंद के। यह क्लास में हम पाइथन में, क्लास में हम सी में करवा रहे हैं। पर तुम्हारा जो भी तुम्हारा कंफर्टेबल है कोडिंग लैंग्वेज में, तुम उसमें करो।
यस
कोडिंग का कोई दिक्कत नहीं है। तुम ध्यान दो कि तुम डीएसए समझ पा रहे हो कि नहीं, ठीक है। क्योंकि अगर
सर।
ये समझ नहीं पा रहे हो तो सीएस में दिक्कत होगा बाद में।
सर एक बार फिर से कोर्स का नाम क्या बताएं? ओपन एम आई टी?
एमआईटी ओपन कोर्सेज, एमआईटी ओपन कोर्सेज, ये यूट्यूब में इसका बहुत सारे मतलब उनका बहुत सारा कोर्सेज चलता है। तो उसमें डेटा स्ट्रक्चर एंड एल्गोरिथम भी है। तो उसका शायद दो पार्ट है उसका। तो एक एक पार्ट में 50-60 लेक्चर होंगे लगभग। वो एक सेमेस्टर का लेक्चर होता है। तो वहाँ पे ये सारे टॉपिक्स कवर किया है, ठीक है। जितना भी टॉपिक्स है इधर वो उधर कवर्ड है। तो अगर तुमको यहाँ समझ नहीं आ रहा है तुम उधर भी देख सकते हो। पर मुझे
सर
लगता है
कोई
कि और बुक चाहिए तुमको तो तुम कॉर्डमैन एक है, कॉर्डमैन का बुक फॉलो कर सकते हो। ये तुमको ऑनलाइन तो शायद नहीं मिलेगा, पीडीएफ नहीं मिलेगा वैसे।
अमेजोन फ्लिपकार्ट से मिल सकते हैं?
ओ हाँ, वहाँ पे मिल जाएगा, वहाँ पे तो मिल जाएगा लेकिन कॉस्टली है। पर
कॉस्टली है?
वो
सर लाइब्रेरी
हाँ,
में अवेलेबल होगा? सेंट्रल लाइब्रेरी कैंपस, कॉलेज कैंपस,
कैंपस में तो है पर
आईआईटी
तुम
पटना में?
लोगों को अलाउ है कि नहीं वो पता नहीं। अगर
सर
अलाउ है
मैं
तो यहाँ
फोटो
पे आके
जाके खींच
पढ़
सकता
सकते
हूँ।
हो। ओह अच्छा अच्छा। वो तो पता
और
नहीं
सर एक
अलाउड है
और
कि नहीं।
रिक्वेस्ट था कि सर क्या
हाँ
मतलब अभी तो आपने इंग्लिश में बता दिया ओपन एमआईटी ओपन कोर्स, कोई ऐसा हिंदी में
हाँ
कोई प्लेलिस्ट इन इंग्लिश?
हाँ, हिंदी में मैं बता रहा हूँ, वही गेट का जो बता रहा हूँ ना, गेट गेट एग्जाम जो है सीएससी का। तो उसका
यस सर।
कुछ लेक्चर्स वीडियो होता है, मतलब उसके लिए बहुत सारे लेक्चर्स वीडियो होता है। तो मुझे अभी वो चैनल का एग्जैक्टली याद नहीं आ रहा, पर तुमको वो तुम गेट सीएससी लिख के सर्च देना, गेट सीएससी डीएसए। बहुत सारे वीडियोस आएंगे, तो उनमें से देख लेना, तुमको मिल जाएगा हिंदी हिंदी में जो डीएसए कवर कर रहा है हिंदी में।
यस सर। थैंक यू सर।
हम्म, ठीक है, ठीक, कोई बात। ओके, so I'm closing the meeting. Okay, any other questions? So I guess no. So thank you everyone. I'm ending the meeting.
थैंक यू सर।